Question 5, continuing from 3 and 4, where we're going to have a problem finding the particular integral. We'll find out why by looking at the left-hand side. So with our complementary function here and the auxiliary equation giving us m minus 1 squared equals 0, and so m is equal to 1, which tells us that the format we're going to have is a plus bx e to the x. So if you notice, that includes an a e to the x, so we couldn't have a complementary function of y equals lambda e to the x. That's no good because it clashes with that. But our backup is normally to do an x, but look, we've got some x e to the x's as well, so we can't have lambda x e to the x. We can't have that either because it clashes with this. So you have to write that in words, but what it means is we're going to have to go all the way up to a x squared e to the x to try and figure out what this gives. So differentiating an x squared e to the x, so dy by dx here, that's going to be a product rule of lambda x squared e to the x plus 2 lambda x e to the x, and differentiating again, should we do it? I mean, sometimes I'd actually just factorize that out as an e to the x, but we'll do it again. So that's what we just did, isn't it? So that's lambda x squared e to the x plus 2 lambda x e to the x. That's what that gives. And then this bit here gives 2 lambda x e to the x plus differentiate the first bit, which just gives me 2 lambda e to the x's. Should we tidy that up here? So that gives us lambda x squared e to the x. These two should be the same, yes. 4 lambda x e to the x plus 2 lambda e to the x. So there's the differentiating done. Now we need to substitute that into the original, which said dy by dx. You know what? I'm going to miss out all the e to the x's just to make the writing simpler here. So dividing everything by e to the x as I do it. So there's dy by dx. Take away d2y by dx squared. Take away 2 lots of dy by dx. So minus 2 lambda x squared minus 4 lambda x. And finally plus y. So plus lambda x squared. And we want that to simply equal 1. Right, having made a mistake in the last one, I'm going to use the the simultaneous equation solver here. So x squareds, actually, do we need to? X squareds, lambda x squareds minus 2 lambda x squareds, lambda x squareds. That works because we don't want any x squareds. Then x's. 4 lambda x, take away 4 lambda x. That disappears as well. Oh, we don't need the calculator at all because we've just got 2 lambda equals 1, and so lambda equals a half. The answer to the end of the question is that y equals a plus bx e to the x plus a half x squared e to the x.